Now in this part of the question then we're given that the random variable x is normally distributed with mean mu and variance of 25 or 5 squared. And we're also told that the probability of x being less than 23 is equal to 0.9192. And we've got to find out what mu is, the mean. Now if I'm doing any question like this, or any question anyway on the normal distribution, I will always encourage you to draw a sketch. And we've got a sketch of the normal distribution here for our random variable x, and this value here is the mean mu. And then I would put underneath that the standardized normal distribution z, which has a mean of 0. Then we need to add this information to the diagram. We've got that the probability of x being less than 23 is 0.9192. So we're looking at the area then to the left of 23 has got to be easily over a half here. As you can see, 0.9192 is more than the half, so it means that our value of x being 23 has to be to the right of the mean mu. So if we just stick it there, okay, that this is our observed value, little x, okay, which is equal to 23. And we can shade in that area to the left here of 23 is going to be equal to 0.912. So in other words, what we're saying is that the probability of x being less than the little x here, if you like, okay, is equal to 0.9192. That's that area in there. Now what I would want to do is project this back down onto the standardized normal distribution, and we've got this z value here, which I'm going to call z1. And remember, z1 is a measure of how many standard deviations this observed value is away from the mean mu. We know that this area in here must be the same as the area up here. So in other words, the probability that z is less than z1, that has to equal 0.91, just get it in there if you can see that, 9192. Alright, a bit cramped, but as I say, I hope you can see that. So we should know that there's a connection between any observed value up here to the standardized value down here. That connection is given by the formula z equals x minus mu all over the standard deviation, sigma. Okay? So how does that pan out for us? Well, it means that z1 must equal the corresponding observed value, which is 23, minus the mean mu all over the standard deviation. And remember, the standard deviation here is 5. This is the variance, 5 squared, the standard deviation squared. So the standard deviation is 5. Now we can't get much out of this until we've discovered what z1 is. So we'll put that one on hold, we'll call it equation 1, and we'll just come down through here, and we've got to work out what z1 is. So we know that the probability that z is less than z1 is given as 0.9192. So put that down there, 0.9192. And we have to go back to our tables. So from tables, let's just draw up the tables. You should have a set of tables that look something like this, where they give you the tabulated values of a probability being less than a given z value. And so what you've got to look for is a z value in this column here, which is 0.9192. And then in the tables that I was looking up, the corresponding Z value was 1.40. So we can see that from tables Z1 is equal to 1.40. So all I need to do is just substitute this into equation 1, and if we do that we're going to find that we can work out what mu is, because we've got 1.40 then equals 23 minus mu over the standard deviation 5. And if we multiply both sides by 5 and then rearrange this for mu, you'll find that you get mu equals 23 then minus 5 multiplied by 1.40. And that comes out at 16 exactly. Okay, so there you go. Mu is equal to 16.